Assalamualaikum. My name is Nunabila Alia binti Muhammad Hasdi.
Meet my amazing teammates, Nuri Akilah binti Ibrahim, Tengku Ayuni Safia binti Tengku Anwar, and Ifai Emir bin Zayani.
From Group 2, representing two topics under application of differentiation. One is the apply of maximum and minimum problem, and the second one is related rates.
What is differentiation? Differentiation is a method of finding the derivative or the rate of change of a function. The rate of change of a function is defined as dy over dx or fx or y. The application of differentiation is related rate, determine increasing and decreasing function, maximum and minimum, and also most theorem.
As for applied minimum and maximum problems, me, Nurin Akilah, and Tengku Ayuni will be guiding you to solve this question. You might be wondering what it is actually applied maximum or minimum problem. Well, it is the process of finding maximum or minimum values that is called optimization. There are many application problems in calculus in a function to find maximum or minimum values. Objective of applied minimum and maximum problem in real life usually used to maximize the profit in a company or minimize costs to make particular object. While in calculus, we used to calculate the highest and lowest point of the curve in a graph or to know its turning point. Why do we need to use applied maximum and minimum problem? First, to increase understanding about application of differentiation. Second, to understand apply of maximum and minimum problems. And the last one, to be able to solve the question by using the suitable formula. Problem statement. A piece of wire of length 120 cm is bent into the shape as shown, given that PTS is a semicircle. A. Express y in terms of x. B. Show that the area ACM enclosed by the wire is given by A equals to 60x minus 1 over x square minus 3 over 8 pi x square. C. Find the value of x and y for which A is maximum. D. Find the maximum area. Let's solve for the first question. Express y in terms of x. First, we need to find the r. Since P to S is at cm, to find r, we need to divide by 2. So r is equal to x over 2. Next, we need to find perimeter of semicircle. Perimeter of circle is 2 pi r. So substitute r equal to x over 2. Then we get perimeter of circle for this question is pi x. Since we want to find the perimeter of semicircle, we just need to divide it by 2. So perimeter of semicircle is equal to pi x over 2. To express y in terms of x, we need to generate an equation of perimeter based on the given question. So we will get y plus x plus pi x over 2 equals to 120 cm. Since we need to express y in terms of x, so y need to be on the left hand side. We will get y equal to 120 over 2 minus x over 2 minus pi x over 2 over 2. Then simplify, we will get the final answers for this question is y equal to 60 minus x over 2 minus pi x over 4. For question B, show that the area ACM enclosed by the wire is given by A equal to 60x minus 1 over 2x square minus 3 over 8 pi x square. First, we need to generate an equation to find area that enclosed by wire. So, we will get A equal to x y minus 1 over 2 pi multiplied by x over 2 square. Substitute y from question A into this equation. We will get x multiplied by 60 minus x over 2 minus pi x over 4 minus 1 over 2 pi multiplied by x square over 4. Then, we will get 60x minus 1 over 2x square minus pi x square over 4 minus 1 over 2 pi multiplied by x square over 4. Simplify, we will get final answer same as given in the question, which is A equal to 60x minus 1 over 2x square minus 3 over 8 pi x square.
Questions to find the value of x and y for which A is a maximum. This question have two. For the first question is we need to differentiate the area, which is the A over dx equal to 60 minus x minus 3 over 4 pi x. So the A over dx equal to 0. 60 minus x minus 3 over 4 pi x equal to 0. And then simplify the equation and get the answer for x, which is 70.888. And after that, we need to exchange the value of x into the first equation. For which A is maximum, we need to second derivative test the first equation of the first derivative test that we just did, where we get d square a over dx squared equal to -1 minus 3 over 4 pi when x equal to 17.88. The second derivative class equal to negative, which means that a is a maximum. Let's to push where we find the maximum area. The equation for area is 8.216x minus 1 over 2x squared minus 3 over 8 by x squared. So that we need to exchange the value of x inside the equation with 17.80. And after that, we get the maximum area, which is 536.32. One question, therefore, identifying the right formula and accomplishing both first and second derivative correctly will lead to a solid answer, a maximum or minimum cost.
Now, I will be discussing the topic about related. For the introduction, the differential calculus related rates problems involve two or more variables that changes at the same time, possibly at different rate, and the rate of the change is usually with respect to time.
Hi, I am Nabila and I will tell you the objective of related rates. In a related rates problem, the idea is to compute the rate of change of one quantity in terms of the rate of change of another quantity, which may be more easily measured. The procedure is to find an equation that relates the two quantities and then use chain rule method or implicit method. Problem statement: a water tank in the shape of a cone is filled with water at a constant rate of 3 meter power of 3 h power of -1. The radius of the tank is 3 meter and the height of the tank is 9 meter. At what rate is the depth of the water in the tank changing when the depth of the water is 6 meter? To solve the question, we need to understand the problem, identify given information that we got from the question, and identify what rate we need to find. From the question, we got to know that the tank is filled with water at constant rate of 3 meter power of 3 h power of -1. That means we will write it dV over dt equal to 3. The meaning of dV over dt is actually the first derivative of volume with respect to time. It shows how volume changes with time. We also know that the radius of the cone is 3 meter and the height is 9 meter. Next, the question asks to find the rate at which the depth of the water is changing when the water depth is 6 meter and radius 3 meter. So we need to write it as dH over dt equal to question mark because we still don't know the answer. To solve it, first we need to relate radius to height, which we will write as r over h equal to 3 over 9. When we simplify, it will be 1 over 3. Therefore, the radius of the water at any height is r equal to h over 3. Moving on, we need to use chain rule method to solve the question. We need to write dH over dt equal to dV over dt multiplied with dH over dV. From the question, we already know the value of dV over dt, which is 3. So, we only need to find out dH over dV only. Next, to find dH over dV, we need to know and write the formula for value of cone. What is the formula for value of cone? The formula is V equal to 1 over 3 pi r square h. Just now, we find out that r is equal to h over 3. So we need to substitute it into the formula. After that, we will get pi h power of 3 over 27. That's all from me. For the next step, I will pass it to Irfan.
Alright, continuing on, we have to get dV over dH, which is equals to pi over 27 times 3h power over 2. We have to then differentiate again to 3 pi h power over 2 over 27. Again, we have to do it exactly the same, which is we get equals to pi h power over 2 over 9. And lastly, we have to get dH over dV, which is equals to 9 over pi h power over 2, which is the same as above, but we have to twist it, turn it around a bit. And then lastly, in order to get the answer for dH over dt, which is equals to 3 times 9 over pi h power over 2. The h for the part of the h, we have to change it to 6 because of the water is the question is it asks for 6 meter. So h power over 2, h is we have to change it to 6, so it's 6 power over 2. After getting the calculation, our final answer will be equals to 3 over 4 pi. Alright, in conclusion, thus, if we know how the variables are related and how fast one of them is changing, we can figure out how fast the other one is changing. Moreover, by understanding the question, we can solve them easily.